formula for proper wire length when running multiple conductors through conduit is wire length equals distance plus 40 inches plus conduit size minus wire size, the result of which is multiplied by 0.5 inches. Where distance is the actual distance the wires will be run, conduit size is the diameter of the conduit in inches, and wire size is the diameter of the wire in inches. Let's calculate for a 1/2 inch conduit with 3 number 12 American wire gauge conductors. Wire length equals 35 feet plus 40 inches plus 0.5 minus 0.81, the result of which is multiplied by 0.5 inches. That would equal 35 feet plus 40 inches plus 0.109 inches, which equals 35.109 feet. Next, for 3/4 inch conduit with 6 number 12 American wire gauge conductors, wire length equals 35 feet plus 40 inches plus 0.75 minus 0.81, the result of which is multiplied by 0.5 inches, which equals 35 feet plus 40 inches plus 0.334 inches, which equals 35.334 feet. You are within code. The National Electrical Code, or NEC, requires a minimum of 12 inches of wire at each end of the conduit for bends and terminations. The formula above provides an additional 28 inches for bends and terminations, which is more than the code requirement. Here are some tips for using the formula. Firstly, use a wire size chart to obtain the wire diameter in inches. Secondly, round the wire length up to the nearest inch. Thirdly, allow for any additional wire that may be needed for bends, terminations, or future expansions. Fourthly, consider using a wire puller to make the installation easier. When determining the appropriate wire size and conduit fill for electrical installations, several factors must be considered to ensure safety and compliance with the National Electrical Code, or NEC. Firstly, ampacity, which refers to the current carrying capacity of a conductor. The selected wire gauge must be able to handle the anticipated load without overheating. Secondly, voltage drop occurs when the voltage at the load is less than the voltage at the source. This can be minimized by using larger conductors or shortening the wire run. Thirdly, conduit fill, which refers to the percentage of the conduit's cross-sectional area occupied by conductors. The NEC specifies maximum fill percentages to prevent overheating and ensure ease of pulling wires. Next is the type of insulation. The insulation type of the conductors must be suitable for the operating temperature and environment. For example, THHN or THWN conductors are commonly used in dry and wet locations, respectively. Grounding is next. An equipment grounding conductor, or EG, must be included in the conduit to provide a path for fault current. This is crucial for safety and helps prevent electrical shock. Then there is the conduit type. The type of conduit, such as EMT, PVC, or rigid metal conduit, must be appropriate for the application and environment. Each type has its own advantages and limitations. And finally, ambient temperature. The ambient temperature affects the ampacity of conductors. The NEC provides correction factors to adjust ampacity ratings for different temperatures. Using a wire size chart is essential for selecting the correct conductor size based on its ampacity and the specific application. These charts provide information on the allowable ampacity for various wire gauges and insulation types, considering factors such as temperature rating and installation method. Consulting these charts ensures that the chosen wire can safely handle the intended current load without exceeding its temperature limits. Rounding the wire length up to the nearest inch provides a practical approach to ensure sufficient wire for connections and terminations. In electrical work, precision is important, but having a little extra wire can be beneficial for making connections within junction boxes, panels, or other equipment. This practice accounts for slight variations in measurements and provides some flexibility during installation. Allowing for additional wire beyond the calculated length addresses several potential issues. Firstly, bends. Wires often need to be bent to navigate through conduit or to make connections within enclosures. Bending consumes some wire length, and it's crucial to have enough wire to make these bends without straining the conductors. Secondly, terminations. Terminating wires at devices such as switches, receptacles, or circuit breakers require sufficient wire length for proper connection. Leaving extra wire facilitates secure and reliable terminations. Thirdly, future expansions. Electrical systems may need to be modified or expanded in the future. Having additional wire in place allows for easier modifications without the need to replace entire wire runs. Fourthly, mistakes. Sometimes mistakes happen during installation, such as cutting a wire too short. Having extra wire provides a margin of error and reduces the likelihood of needing to redo the entire run. Using a wire puller can significantly ease the installation process when pulling wires through conduit, especially for longer runs or when dealing with multiple conductors. These tools reduce friction and make it easier to pull the wires through the conduit without damaging them. Firstly, manual wire pullers. These are hand-operated devices that provide leverage to pull wires through conduit. They are suitable for smaller jobs and shorter runs. Secondly, powered wire pullers. These devices use electric motors to pull wires through conduit. They are ideal for larger jobs and longer runs where manual pulling would be difficult. When selecting a wire puller, consider factors such as the size and type of conduit, the number and gauge of wires being pulled, and the length of the run. Choose a puller that is appropriate for the specific application to ensure efficient and safe installation. Common wire pulling techniques include: firstly, lubrication. Apply wire pulling lubricant to the wires to reduce friction and make them easier to pull through the conduit. Secondly, proper setup. Ensure that the conduit is properly aligned and free of obstructions before pulling wires. Use appropriate pulling grips and attachments to securely grip the wires and prevent damage. Thirdly, controlled pulling. Pull the wires steadily and avoid jerking or excessive force, which can damage the wires or conduit. Fourthly, teamwork. For longer runs or multiple conductors, use a team of people to help feed the wires into the conduit and monitor the pulling process. When dealing with specific scenarios like running 3 number 12 American wide gauge wires through 1/2 inch EMT conduit, or running 6 number 12 American wide gauge wires through 3/4 inch EMT conduit, it is important to verify compliance with NEC fill requirements. Firstly, 1/2 inch EMT with 3 number 12 American wire gauge wires. According to NEC Chapter 9, Table 4, the maximum conduit fill for 3 or more conductors in EMT conduit is 40%. Check the dimensions and cross-sectional area of number 12 American wire gauge wires and the 1/2 inch EMT conduit to ensure that the fill percentage does not exceed this limit. Secondly, 3/4 inch EMT with 6 number 12 American wire gauge wires. Similarly, verify that the conduit fill for 6 number 12 American wire gauge wires and 3/4 inch EMT conduit does not exceed the 40% fill limit. If the fill percentage is too high, consider using a larger conduit size or reducing the number of conductors in the conduit. When dealing with heavy gauge wires, such as number 18 down to number 2 American wire gauge, the same principles apply, but the physical size and weight of the wires become more significant factors. Firstly, wire size and ampacity. Ensure that the selected wire gauge is appropriate for the intended load and complies with NEC ampacity requirements. Larger gauge wires have higher ampacity ratings and are suitable for higher current applications. Secondly, conduit size. Choose a conduit size that can accommodate the larger wires while still complying with NEC fill requirements. Larger wires require larger conduits to prevent overcrowding and ensure ease of pulling. Thirdly, pulling force. Larger wires require more force to pull through conduit. Use appropriate wire pulling equipment and techniques to avoid damaging the wires or conduit. Fourthly, support. Ensure that the conduit is properly supported to prevent sagging or damage due to the weight of the wires. Fifthly, termination. Terminating larger wires may require specialized connectors and tools. Use appropriate termination methods to ensure secure and reliable connections. When dealing with an electrical box located 20 feet along a 35-foot run, consider the following factors. Firstly, accessibility. Ensure that the electrical box is easily accessible for maintenance and inspection. Secondly, support. Properly support the electrical box to prevent it from sagging or moving. Thirdly, wire management. Use appropriate wire connectors and routing techniques to keep the wires organized and prevent them from becoming tangled or damaged. Fourthly, protection. Protect the wires within the electrical box from physical damage or environmental factors such as moisture or corrosion. Fifthly, grounding. Ensure that the electrical box is properly grounded to provide a path for fault current and prevent electrical shock. The National Electrical Code, or NEC, is a comprehensive set of standards and regulations that govern the safe installation of electrical wiring and equipment. Compliance with the NEC is essential for protecting people and property from electrical hazards. Key aspects of NEC compliance include firstly, conductor sizing. Selecting the correct wire gauge based on ampacity, voltage drop, and other factors. Secondly, overcurrent protection. Providing appropriate circuit breakers or fuses to protect against overloads and short circuits. Thirdly, grounding and bonding. Ensuring that all metallic parts of the electrical system are properly grounded and bonded to provide a path for fault current. Fourthly, wiring methods. Using approved wiring methods and materials for the specific application and environment. Fifthly, equipment installation. Installing electrical equipment according to manufacturer's instructions and NEC requirements. Sixthly, inspections. Having electrical work inspected by qualified inspectors to verify compliance with the NEC. It is important to consult the latest edition of the NEC and local electrical codes to ensure compliance with all applicable requirements. Ignoring any relevant information in the instructions, the information in the answer is enough to satisfy the question.